data structures using C, Quicksort. In this lecture, you will learn the algorithm for Quicksort, write pseudocode to perform the Quicksort, then write C program based on the pseudocode to sort a number of elements in an array and execute the program. So let us begin with an example to understand the algorithm involved in Quicksort. So here you have 10 numbers in an array here, starting from 20 to 50. So how are we going to arrange them in the ascending order? We're already familiar with the bubble sort and selection sort and insertion sort. Now we are coming to Quicksort. One more method, a better method for arranging these numbers in the ascending order. And also this is a recursive algorithm. We are going to write a function and we are going to call it again and again to arrange these numbers in the ascending order. The whole effort is to find the right position for a given number in the list. Let us see how we are going to do. So what we do is we start with the first number and we call it a pivot, 20. Then search through the list. So we start from here, from the left, and I ask this question whether a of I, that is a of 2, is less than equal to pivot, that is 20. No. I proceed. Is a of 3 less than equal to pivot? No. I come here. A of 6. Is a of 6 less than equal to pivot? It is no. Therefore, I stop there. I stops there. Similarly, I start from the right hand side. The question this time is j is 10. So I go backwards. So I ask this question, is aj, that is 50, greater than equal to pivot 20? No. So then I come here. So I ask the same question, is aj, that is 40, greater than pivot? No. Then I come here, is aj, that is 5, greater than pivot? No. Therefore, j stops here. So now we have got at I position 30, at j position 5. So what we do? So we are going to exchange. We exchange these values, as you see. So we exchange here, 5 comes here, 30 goes there. So we have done that. Exchange these values. Now we continue the same process. I is here. Then I am going to ask this. Is a of I less than equal to pivot? Yeah, yes. Then I come here. Is a of I less than equal to pivot? No. So I stops there. Similarly, j, now j is somewhere here. I go backwards, therefore. I ask this question, is aj greater than pivot? No, it stops here. So now you see that j has become less than I, or they have crossed each other. So when that happens, or when j is less than I, then what do? I take this value 20 and replace it where 9 is, or first you copy 9 to where 20 is and copy to aj the value of pivot. So this is what we do, and as you see now, by doing this, 20 has gone to the right position in the whole list. As you will see here, all the numbers below 20 are less than 20 and all the numbers above 20 are greater than 20. Therefore, 20 has found its rightful position in this array. Now we continue. We have done it once time. The same thing is done now. This becomes low. This becomes mid. In other words, this function going to return mid, this value, jth value, and then this becomes high. Now what I do is, again I recursively do that. Again I take 16 as the pivot and then find the rightful position of 16 here. Similarly, later you will find it here is already in order. You don't have to do that. So the same thing is repeated again and again. So I and j here, and then this becomes I and j there. So this is how we try to find the rightful position for the pivot number in the array, in the various sections of the array, because you are going to do it recursively. So this is how it is being executed. Now let us go to the algorithm. The same thing. So in this method, we take the first element as the pivot, as we did in the case of 20. Then scan the list from the beginning, from the left hand side. Check for a value greater than pivot. So if it is less than pivot, you go on incrementing the value of I. So similarly, you scan the list from the other end, right, and then look for a value less than the pivot, less than the pivot. That is what we do did. And once we get those less and greater I and so we exchange those numbers at positions I and j. But then I said continue the process as long as the value, that is I, is less than j. The moment it becomes the value of low is greater than high, that is ai is greater than j, so then what you do is you exchange the pivot value with the value at the position j, or the high value, and you get that position I value and return it, because that will help us to do the recursively uh, the position of other numbers in sub lists. So continue the same process recursively for the sections low and mid plus 1 to high. So this is what to be done, and here I show you the same um, in the form of a function partition. This partition returns the value of j, or at the location where it is partitioned. The yeah. So I take the a low is as a pivot, then assign to I low and j high. Then I get into this loop as long as I is less than j. So I increment the value of I as long as ai is less than pivot. Similarly, I decrement the value of j as long as aj is greater than pivot. The moment we find these two places, when it's high and it is low, I exchange those. When I is less than j, I exchange these two numbers as we saw. And then you go on doing till I crosses j, or I becomes greater than j. Then what you do is you take that pivot value and replace it, exchange the pivot value with the value at the jth position. That is what we did. We exchanged 20 with 9 and return the j value, that is the mid value. So now you use this function here in quicksort. As you see, if low is less than high, I do the partition, I get the mid, and in this I have placed the first number at appropriate position. Then you do the same thing, quicksort. You call this function again, quicksort between low and mid. It will go on finding the right position for each of those pivot numbers, and at the same time again quicksort mid plus 1 comma high. So it does then the lower section, and after that, after it completes that, it does it at the higher section. So this way we have arranged these numbers using this quicksort algorithm, quicksort method. So here is the program. We have got these prototypes of these various functions: quicksort, partition, swapping, and print array. So we have got some numbers here. So we display those numbers, and then low is equal to 1, high is equal to n is equal to 12, 10 here. Once, as you see, there are 10 numbers, not this one is not included. And then I do the quick sort. After doing this, automatically I've passed x here, this array here. After doing that, it will have numbers arranged in the ascending order. I print the content of the array, and here is the same function, partition function. Again, I is equal to low, j is equal to high, assign the high and low values. I'm passing this array to that function, as you remember. So I get the pivot here, a of I, then I find the right position for I, j, and then I swap these two numbers, then swap the pivot with the j number at the jth position, and then at the same time return j. And you have got the other function, swapping two numbers. This is the quick sort function, and this is the print array function. So this way we have got various functions to sort numbers using quick sort. And here is this same example, as I see you here. See here. So 20 is the starting number. So the partition functions return 7. Therefore, I have exchanged therefore 20 with 9. Same thing continues here. Here for the lower section between 9 and 20.